All right, let's go ahead and get on with our lesson today. 5.3 Inequalities in one triangle. Our ICANN statement for today is I can recognize and apply properties of inequalities to the measures of the angles of a triangle, as well as I can recognize and apply properties of inequalities to the relationships between the angles and sides of a triangle. So starting off here with our definition of inequality. So I don't necessarily want to pay too much attention to these words up here because they can get really confusing. But basically, let's just say we had the number 7, and I took two numbers, any two numbers I can add to give me 7. Let's say 4 and 3. So 7 is equal to 4 plus 3. Well, what this definition of inequality says is if we can take two numbers to add to give us one big number, then that one big number automatically has to be greater than those two small numbers. So if we could take 7 and split that up into 4 plus 3, well, that means that 7 has to be greater than 4, and 7 has to be greater than 3. Now, you guys probably already knew that. You're probably like, Mr. Sharp, I learned that in kindergarten. What are we talking about here? Well, let me show you how that directly applies to our geometry here. So again, I just wrote down what we had on that last page. We took 4 plus 3. We said that was equal to 7. Since we added those two numbers to get 7, we said 7 is greater than 4 and 7 is greater than 3. Well, we had this thing called the exterior angle theorem a while back, and what that was is we had an exterior angle, and we said that the exterior angle was equal to the sum of the two remote interior. Hopefully you guys remember those words, remote interior. And what that meant was just the two angles that were furthest away. Okay, so obviously here A, B, and C. C is definitely the closest angle to angle 1, so the two remote interior angles would be A and B. Okay, so they said angle 1, let's say, is an exterior angle that's equal to the sum of the two remote interior angles, or angle A plus angle B. Now, just like what we did up here when we said, hey, if we can add these two small numbers to give us one big number, then that big number is automatically smaller than those two other numbers. We can do that same exact thing down here. Okay, so we can say that angle 1 is not equal to, but we can say that angle 1 is greater than angle A, and we can also say that angle 1 is greater than angle B, right? Because we added both of those angles together to get angle 1, all right? So what this is all about is we are able to say here that the exterior angle is always greater than the remote interior angles, okay? So our big thing today is we're going to be identifying remote interior angles and saying, you know, which angle is greater or less than based on that theorem. So we are going strictly exterior angle theorem. Now, we got this question here. It says use the exterior angle inequality theorem to list all angles whose measures are less than the measure of angle 14. So we're going to come up with a little cheat sheet here that will help us remember what we're looking for. So we have a less than question. We're talking about the measure of angle 14. I noticed that the measure of angle 14 is an exterior angle. So if I want to find angles that are less than an exterior angle, what we are going to look for is we are going to look for some interior angles. So go ahead and write that in your notes if you don't have it already. Less than, anytime we get a less than question, we're going to look at interior angles. So the question that I have here is basically what are the remote interior angles if angle 14 is our exterior angle? Okay, so we're looking at this green highlighted triangle here. Looks like angle 14 would be an exterior angle to this triangle. So the two remote interior angles here would be 4 and 11. All right, those are the two angles furthest away from angle 14. So 4 and 11, those would count as our first two angles here that are less than 14. Now let's take a look and see if there's any other ones. Now, looks like 14 here is exterior to that triangle that we did have highlighted, but it's also exterior to this full big triangle. Full big triangle. Okay, so talking about this full big triangle, I want to draw this to make it separate from everything else. Okay, the reason I want to do that is it may help us see things a little bit better. So 14 was on the outside. We had 5 over here. We also had 4. We have 3, and we have 2. But when we go to put in 10 and 11, I notice neither of those angles are here. Right? There's no angle here. This is just a flat line. So there's no angles on this flat line. So we don't even need to include 10 or 11 in this. But looking at the angles we've already mentioned angle 4. Right? We've already mentioned angle 4, which we did that right up here when we did the first triangle. So the only angles we have in this triangle now are 5, 2, and 3. And I want to go ahead and circle the two remote interior, or the two angles that are furthest away. So much like in that first triangle, angle 5 is the closest. So our two remote interior angles here would be angle 3 and angle 2. Angle 3 and angle 2. So that right there, those 4 angles are going to be our final answer, because there are no other triangles in which angle 14 is an exterior angle 2. Now let's kind of switch it up here. Let's go from a less than question to a greater than question. So we're talking about the measure of angle 5 here, and we want to know what angles are greater than the measure of angle 5. Now when we look at the measure of angle 5, looks like angle 5 is an interior angle. So if we are looking for angles that are greater than an interior angle, we are going to be looking for exterior angles. So anytime you get a less than question, we're going to be looking interior. Anytime you get a greater than question, we're going to be looking exterior. Now, again, I want to highlight the triangle that angle 5 is in. Highlight the triangle that angle 5 is in. Now, I want to ask myself this question. What exterior angle makes angle 5 a remote interior angle? What exterior angle makes angle 5 a remote interior? Well, I see angle 14 is exterior, but the two remote interior angles to angle 14 we already know are 4 and 11, right? So since angle 5 was not listed there, we are not going to say angle 14. Another exterior angle here I see is 17. Well, let's figure out the two remote interior angles for 17. Those would be 11 and 5. 11 and 5. So since we said angle 5 in that, we can say that angle 17 is an exterior angle that makes angle 5 a remote interior, which means that angle 17 is greater than angle 5. Okay, angle 17 is greater than angle 5. Now let's go ahead and look elsewhere. So if I'm looking specifically at this green triangle, any angle that is outside of this green triangle would be considered, an exterior angle. Now, the only way that we can make sure that, that this is a for sure exterior angle is if they continue on a line that's already in the triangle. So as you can see, these two lines and our two sides of this triangle kind of extend, and we get these two exterior angles, angle 10 and angle 12. Okay, so let's go ahead and just test these out to see what would be our remote interior angles to these exterior. So if we looked at angle 10, looks like the two angles furthest away from angle 10 would be angle 4 and angle 5. Angle 4 and angle 5. So again, since we mentioned angle 5 as a remote interior, we can say that angle 10 is going to be greater than angle 5. Okay? So angle 10 is one of our greater than angles. Lastly, angle 12, what would the two angles that are furthest away from angle 12 be in our green triangle? It looks like it would be angle 4 and angle 5. So again, because we mentioned angle 5 as a remote interior, we're going to say here that angle 12 is an exterior angle that is greater than the measure of angle 5. Okay. Now looking at any other angles, I'm not seeing anything. So 15, it's kind of catty-cornered. Anything that's catty-cornered won't work. Same thing goes with 9, right? 9's kind of catty-cornered to this little triangle. Same thing goes for 16. So I'm not really seeing anything that would be beneficial to us or help us out here. So it looks like our final answer is going to be angle 17, angle 10, and angle 12. Now, if you have not already, go ahead, pause the video and do these questions. So we got an A, we got a B. So go ahead and pause at the beginning of both of these and get your answer. I'm going to go through each of them as you see them. So make sure you pause to give yourself an opportunity to work on these on your own. So for this question here, we have a less than question. So we're talking about less than the measure of angle 4. So hopefully you guys remember anytime we had a less than question, we were talking about interior angles. right? Interior angle. So I want to ask myself here, what is a remote interior angle to our exterior angle, angle 4? So angle 4 would be exterior to this first red triangle. So what are our two remote interior angles here? Well, angle 3 would be closest to angle 4. So the two angles furthest away are going to be angle 5 and angle 2. So far I know we have angle 2, we have angle 5. And then I want to look back at this triangle again because I see that angle 4 may be an exterior angle, not just to this small triangle, but also this big triangle right here. Okay, so we have angle 4 right here. Now looks like this was 3. Up here was 2. Up here is 8. Over here is 7. And again, it doesn't appear like we have any other angles in this triangle. These are the only 4 angles that we could be possibly talking about. When we go back to what we did in that first triangle, we've already mentioned angle 2. Okay, so we've already mentioned angle 2. I'm not even going to worry about it because I already know that that's going to be one of our answers. So I'm looking at these 3 angles, 3, 8, and 7. 3, 8, and 7. Now it appears that 3 again is still the closest to angle 4, so that means that our 2 angles furthest away, 8 and 7, are going to be remote interior. So angle 8, angle 7, those are going to be our answers for this. So our final answer here would have been B, 2, 5, 8, and 7. Again, go ahead, pause, and get this one done. Got a greater than question here. Got a greater than. So we got to remember, what are we looking for in a greater than question? So we're talking about the measure of angle 8, which is an interior angle. So if we are looking for measures greater than an interior angle, we are going to look for an exterior angle. All right, so ask yourself the question, what exterior angle makes angle 8 a remote interior? So I'm going to highlight the first triangle that I see with angle 8 in it. Looks like it's this red triangle with 6, 7, and 8. So I'm going to look now for exterior angles that make angle 8 a remote interior. So starting off here, it looks like angle 9. The two remote interior angles for angle 9 would be 8 and 6. So we can definitely say angle 9. Now let's go ahead and look maybe at another exterior angle to this triangle. Remember, it doesn't have to necessarily be outside of everything. It just has to be outside of the highlighted triangle. So angle 5. Angle 5 is also going to be an exterior angle to this triangle. The two remote interior angles to angle 5 would be 8 and 7. So since that's the case, we can go ahead and say that angle 5 is also one of our exterior angles that are greater than the measure of angle 8. Let's take a look here if there are any more. So it looks like 8 is not just in that small triangle, but it's also here in this big triangle. Also here in this big triangle. So looking at the big triangle, I know we've already talked about it in the last question. Angle 4 in the last question we said was greater than the measure of angle 8. So here must be no different. Okay, as you can see, angle 4 is an exterior angle that makes angle 8 a remote interior. So our final answer here would be 4, 5, and 9, which would have been C. Moving on to the second half of this lesson here. The second half of this lesson is pretty straightforward. This is all about the angle side relationships in a triangle. Let's read what this theorem here has to say. It says, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So basically what this is saying is the bigger the side, the bigger the angle is across from that side. Okay, so obviously here we've got XY we said was 9. We've got YZ here that we said was 7. And since XY is greater than YZ, then the angle that is opposite of XY, or angle Z, is greater than the angle opposite the shorter side, YZ, which is angle X. Okay, so we're going to get some examples here that make this a little bit more clear. So let's go ahead and go over those. This first one here, it says list the angles of triangle ABC in order from smallest to largest. So we're going to list all of the angles here in smallest to largest form. And the way that I want to do this, if we are starting with the smallest, I want to go ahead and find the smallest side. So when I look at the smallest side here, it looks like the smallest side is 11.1, or AB. So we want to look opposite of AB, and when we do that, we see that the angle opposite of AB is angle C. So angle C here must be the smallest angle because it is opposite of the smallest side. Next, let's go ahead and do the second biggest side. So that would be 14.3. Now, opposite of 14.3 here, this is side BC, is going to be angle A. It's going to be angle A. Lastly here, just to continue on with this process, the biggest side, 15.7, we want to look opposite of 15.7 to find the biggest angle. So that is going to be angle B. So smallest to largest here, we're going to go angle C, angle A, and then angle B. Go ahead and give this a pause. I apologize about these right here. These should all be angles, not D's. But give this a pause. Go ahead, use this process, find your answer. So I'll go ahead and start here. We are looking at the smallest to largest in the angles. I want to start with the smallest side. So smallest side here is 17.4, which means the smallest angle will be opposite of that. So opposite of 17.4 here is angle X. Opposite of the next biggest side here, 18.5, is going to be angle T. And then lastly here, our biggest side, 20.2, is the opposite of the biggest angle. So that means angle V is going to be the biggest angle. All right, so our answer here, if you were able to figure those out with all of those mistakes in there, would have been A, angle X, angle T, angle V. Now we're going to reverse it. So we're going from, instead of doing sides to angles, we're going to do angles to sides. It's just literally the same exact thing. Okay, the longest side is always opposite the longest angle. So if we're talking here with the shortest side, we want to talk about the shortest side. I want to find the smallest angle. So the smallest angle here is 45. So I know the smallest side here is going to be opposite of our smallest angle. So opposite of angle B is going to be side AC. Side AC. So remember, we got to name our sides with 2 letters with a bar over the top. Now let's go ahead and look at the second biggest angle. Second biggest angle would be 55. So we're going to look opposite of that to find the second biggest side, which is AB. And lastly here, the biggest angle across from the biggest side. So side BC is going to finish up our answer here. So AC, AB, BC. Last one. It says list the sides of triangle RST in order from shortest to longest. So we're doing the same exact thing we did in the last question. Got to start with the smallest angle, look opposite of that smallest angle. So 43 is going to be our smallest angle. Smallest side is opposite of that, so RS. Second smallest angle, 64, opposite of that, second smallest side, RT. Lastly here, biggest angle, opposite the biggest side, ST. So RS, RT, ST. That would have been A.